Okay, let's see. So we're going to try to work this problem right here. We'll call this, the key or something along those lines. I'll use some red because we're writing on here. Okay, so we've got three vectors, and what I'm going to do is I'm going to work them over here. Anyway, you know the problem. For those of you who don't have me, here's the problem. We've got three vectors. I'm going to ask you to draw them. This one's, done in coordinates. This one's got a theta z and a swing angle. And this one's got a theta x and a theta y. And one thing it doesn't have is it doesn't tell you whether z is in the positive or the negative space. And so we'll talk about that in a second. But let's go ahead and work them over here. So I'll go ahead and I'm going to treat this as if this were being turned in. So what I'll do is here's the. Oh no, my lord, that's terrible. All right, you get out the ruler, you think everything's going to be fine. Oh my, okay. I'm going to leave that as a sign of my own incompetence. All right, so anyway, so this is homework 3, from spring of 2022. This is statics class. My name is R. Wayne Wagner, and this is page 1 out of however many we do. Okay, so we're given three vectors. A is 60 newtons, B is 80 newtons, and C is 100 newtons. Okay, note that based on those three numbers, the highest number we could get here as far as the resultant, if we add all three, if those all align, then the largest number we could get is 240. And we could go as small as 0 if these are arranged in a perfect triangle. Anyway, so that's the magnitude of all of these. And this vector goes from the origin through, 350 meters, negative 200 meters, and negative 500 meters. Okay, so it's going through something really far away. Okay, B is 80 newtons, and it's got theta z equal to 20 degrees, and phi is equal to 50 degrees. Okay, so that's that swing angle. Okay, the bottom of the door, and then this one is with theta x equals 35 degrees, and theta y equals 120 degrees. Okay, now I'm going to go into this in a bit, but I should have given you whether or not that was in a positive z or negative z, and we'll talk about that in a second when we get to that one. Okay, but anyway, here we go. Required, I want you to A, draw the vectors. Okay, B, add the vectors. And then C, what is the magnitude of the resultant? Okay. So let's start by drawing this. Hopefully I can do a better job with my ruler than I did a second ago. And let's see, how should we do this? Well, first we need our Z direction. It's going to be straight up and down. Okay. I'm intentionally making that a little bit thick. It's nice to have your axes be something you can see. Based on a few things that I'm aware of in the directions that these things go, I'm going to make X fairly tight onto Z. Hopefully that's a good choice. I can't always tell. So here's X. And then here's Y, somewhere over here. Okay, so this is a right-handed coordinate system. Notice because if X were my fingers, and Y, let's see, and Y is my palm. Okay, then you have to say, well, Z then has to go in the direction of your thumb. Okay, so fingers, palm, thumb. Okay, so if you imagine that, positive X, positive Y, positive Z, then this is the right-handed coordinate system. Okay, if you'd swapped X and Y, this would be a left-handed coordinate system, and we don't really want that. Okay, so the first thing we'll do is I'm going to do A. A will be 350 meters in the x direction. So I'm just going to kind of imagine I'm counting out 350 meters in the x direction. So maybe that's like right there. Negative 200 in the y direction, right here. So we'll go, what, negative 200. Again, I'm just kind of guesstimating here. So if I pull out my my trusty dusty ruler and I try to be as clever, as smart as I can, drawing lines parallel to the x and the y axes. Now I need to go down 500 in the z direction. So let's say like 1, 2, 3, 4, 5. Okay, and actually that's not really the right place for it now, is it? I need to go down 5 from here. So 1, I don't even know. 1, 2, 3, 4, 5. I always forget that these things don't really show up very well for you guys. Anyway, so it would be something like that. Now this one's a little bit annoying because it looks like I almost drew it directly on top of my x-axis, which is definitely not what we want. But we can hopefully make it a little bit more clear by kind of drawing the rest of the box. And some of you guys did this, and I thought that was really pretty smart. If you draw the rest of the box, it begins to look a little bit more three-dimensional. It's hard to draw all the sides, parallel, but it's something like that, right? And so the vector itself, A, maybe we'll make A itself in blue, green or something. Even though it looks like it's going in the same direction as X, right? It's actually going down this way, okay? Somewhere, in the negative Z and the positive X and the negative Y. Okay, so this would be A. Okay, so you could either write an A there, or you could write 80 newtons. It's, something along those lines. Okay, let's go ahead and draw all three because I think I can get them on here. Okay, the next one, B is 80 newtons. And let's see here, we got theta Z is 20 and phi is 50. These are weird because, they usually give it to you in this order, but this is the easier one, or the more important one to think about, is that 50 degrees. So that is measured counterclockwise from positive X. Okay. So we'll find usually. I can imagine some times when that might be different. I don't particularly like this way of defining things. Unless it tells you this, I don't think that's really fair. Usually what's going to happen is you're going to have a diagram, and this is just going to be drawn on there. And so you're going to have to make sense of that. Actually, yeah, let's do this on a separate thing, just so we can have all three of them separate. Okay, so that's A. Let's do B right over here. Okay, it can be nice to have them all on one axis. on one diagram, because it helps you, visualize what the net effect of all three is. But it can also create, crowding. Okay, so let's go over here and let's do. All right, theta Z is 20, and phi is 50. Okay, so phi is 50. So it means we're going to go from this positive x direction towards the y-axis 50 degrees. Okay, and that is towards, what we, normally would call kind of like the bottom of the door. Okay, so that's the bottom of the door there. Okay. Similarly, if I draw this door, this quote-unquote door, because we're going to try to, let's make it a little bit longer so that we can see it. So if I draw the door itself, right, it's going to go up here like this. And then, here's the door. Okay, that's not perfect. I guess I'll have to extend Z up here so that we can, see what's going on here. But anyway, so here we go. Here's a Z up here. Okay, now up there it's hard to see the 50 degrees, but hopefully down here you can see that this is 50 degrees from that axis and 40 degrees from this axis. Okay, so there's the door. Now we need to figure out, well, where is our angle itself? So it's somewhere in that plane, which is, 50 degrees off of positive x. And so what we're going to do is, the other angle we had, which was theta z, is 20 degrees. Okay, so that angle is from theta z, and it is in that plane that we just drew. It's in that door. Okay, so, you know, it's hard to kind of really imagine that. It's hard to draw that. You know, it's not really, I don't know, we'll draw a green vector here. And I'll draw it going through this point right here, even though, you know, who knows, right? With the point of all this being is that this angle right here is 20 degrees. Okay, so this is, you know, the same as this thing right here, just, you know, move down there. Okay, so it is in that door, if I could draw that door. And this, of course, is what, you know, Jeff Hansen would call the blue triangle, which is usually this triangle right here. Okay, we don't normally use that 40, we usually use that 50. But, of course, you could use either one. Okay, so that's usually the blue triangle. Hopefully that's clear enough that you can see what it is. You know, but that's the blue triangle. Okay. All right, so let's do the third one. Okay, the third one, again, let's see, so let's move over a little bit over here. Oh, wait, did we label that? We did not label that. Let's label that B, okay, or 80 newtons. Okay, so then we're going to go over here. Let's do one more. Okay, and I find this one to be the hardest to check out because we're given two things. So theta y is 120 degrees. Theta x is 35 degrees. Okay, and so this leaves kind of a problem, which is we don't know theta z. So the first thing we want to do on this one, this is the only one where you have to really do a little bit of work before you draw it, or you should anyway, is you have to say, okay, well, what is theta z? Okay, so theta z equals who knows what it is. Okay. And so what we do is we do the cosine, let me zoom in over here. The cosine squared of theta x plus the cosine squared of theta y plus the cosine squared of theta z equals 1. Okay, anybody ever want to guess why they do the squareds right there? I don't know, but I find it annoying. Anyway, so what we'll do here is we'll say, okay, the cosine of 35 degrees, okay, and, you know, sometimes it can be nice to remind yourself that it goes like that. Okay, plus the cosine of 120 degrees, okay, squared, plus the cosine squared of theta z equals 1. Okay, so what's going to happen here is, you know, if we do this algebra, let's, I can't find my calculator, but anyway, I'm going to do this, you know, the slow way. Okay, so cosine of 120 is a half, so you square that, you get 0.25, plus the cosine squared of theta z equals 1. So the cosine squared of theta z equals... All right, so this is where things get a little bit interesting, okay? And there's two different ways you can do this. One is you can say, okay, well, the cosine of theta z, if you take the square root of that, is 0. Okay, you can say that it's, you know, 0.28105, or you could do it's like that if you wanted to, okay? And then you could solve this twice, and you could get, well, theta z equals, 78 or 73.677. Or you could solve it for, you know, the negative case, where theta z is 106.32, okay, degrees. Okay, either one of those. The other way to do this, what I typically do is I solve this one, and then note that this one is 180 minus that one. Okay, so it's kind of up to you how you do it, but you know, that'll give you both possible answers. So in this case, everybody in the class just kind of took this answer. So what you're doing here is you're assuming that you're in the positive z space. Okay, and I'm going to describe what that means in a second. Okay, so if I go over here to theta x and theta y, and I imagine I'm just in 2D. Okay, so here's x, and here's y. Okay, now obviously I can't be theta x and theta. I can't do that in 2D because those numbers don't add up, right? They're not going to make it. They're not going to touch. But let's imagine I said theta x. Okay, so theta x. Well, you know, if it's 35, there's two options here. Right? There's a 35-degree angle, there's a 35-degree angle. Okay? So that means that I'm in the positive x direction. So this is positive x, and this is negative x. Okay? And I am this side of the x-axis. Okay? Similarly, if I do the let's suppose I were to do the y direction. Let's use like a, I don't know, a nice pretty green. Okay, and I'm 120 degrees. Well, that means I'm going past 90, okay, in either direction. Now, I don't know which one, right? It's either here or it's here. Okay, so that's 120 degrees. 120 degrees. And so that means that I am not in the positive y space. I'm in the negative y space. Okay, so similarly, now obviously, you know, why aren't these two in the same spot? Okay, and it's because this is in a 3 dimensions. So in 3 dimensions, well, actually, I guess 120 should have been on this side. Anyway, in 3 dimensions, these aren't going to quite align, right? So that 120 and that 35 don't have to add up to 90 like they should in 2D. Or that 120 minus 35. Anyway, so so this z here, we have to decide, you know, whether we need to know if it's positive z or negative z. And so everybody in this class assumed it was positive z. I didn't give you that information. So we're going to go ahead and plot it as if it's in positive z, and we'll solve it that way too. Okay? So, so the thing to note here is that we're in positive x space, negative y space, and positive z space. Now, this is an assumption. Okay, but it kind of helps us figure out how to draw this without, you know, overthinking it, or not overthinking it. We've already overthought it. That's what we're doing here. All right, so positive x space means that, you know, it's on this side of this y-axis, right? Okay, negative y space means it's on this side of the x-axis. All right, now I just need to know if it's up or down, and we assumed it's up. All right, so that means it's above the xy plane. So I guess we've been doing these in green, so I'll go ahead and do that here. So we'll do a nice green line, okay? And it doesn't really matter where it goes. Okay, that's C, or it's 100 newtons, okay? And what we'll do now is we'll label our axes, our angles, right? So we've got a theta x, so it's angle between this and x, 35 degrees. Okay, it looks like I drew that a little large, but you know, what can you do, right? This isn't a drawing class, and you're not a computer, so we do the best we can. Okay, theta y is 120. Okay, that looks pretty good, right? And then theta z is, what do we say, 73.677. So theta z is right here, 73.677 degrees. Okay, so probably I could have drawn this a little bit closer to the x-axis. But anyway, I mean, that's about as much as I would expect from you guys. Okay, so now that we have that, well, let me go ahead and say C is 100 newtons. Okay, B is 80 newtons. And A is 60 newtons. Okay, so, because now what we need to do is we need to add these vectors. Okay, so let's see if we can't... one by one, we're going to kind of break these up into their components. Okay, so we'll start with this one. And I guess I didn't put the coordinates on here, which would have been a nice kind of thing to put here. 350, 200, 500. Okay, so we're at 350 meters, negative 200 meters, negative 500 meters. That's a lot of writing. Nobody likes that. Okay, so what we would do here is we're going to say, okay, A, the vector, let's go back to white. White is what stands out best here. Okay, A equals. Okay, so in the x direction, we went from 0 to 350. So we're going to go 350 meters. Boom. Okay, we're going that in the I. Okay, then in the j direction, I'm going to go 200 meters, negative 200 meters, right? And then in the k direction, I'm going to go 500 meters in the k direction. Okay? I'm going to multiply all of that by 100 newtons. Right? So what I'm doing is I'm going 350 meters in the x direction for every bit I go in the diagonal. Okay? I'm going 200 meters in the negative y direction for every bit I go in the horizontal, and I'm going 500 meters in the vertical direction, negative vertical direction, for something in the diagonal. So we need to know that diagonal distance. So to get that diagonal distance, so that's the length of this line right here. Okay, that is going to be the square root I would put it down here, but let's go ahead and put it down there. The square root, okay, and we'll zoom in, okay? Basically, these three numbers, 300, 350, 200, 500 squared, okay? So it's going to be 350 meters squared plus 200 meters squared plus 500 meters squared. Noticing that the units on that are going to come out to be meters, okay? And that's nice for us because it'll cancel with that meters on the top, okay? So I'll go ahead and just plug it into the calculator and plug it in right here. Okay, so this thing right here is 642.26, so 642.26 meters. Okay, and if you pay any attention to the Pythagorean rule, that makes logical sense. If you have three sides of a three-dimensional triangle thing, and these are their sides, 600 is a reasonable number. Okay, if you had gotten a number bigger than the addition of these three, so bigger than what, 1050, you would have been surprised, or you should be surprised, because that would be impossible. Okay, because if these were all aligned, and they're clearly not aligned, they're on right angles. Okay, so anyway, so that's A. And if I line it all up, then A looks like this. A is, let's see. Okay, we're going to keep 5 sig figs because that's the way I like it. Okay, you can put newtons there or you can put it on the end. I'm going to put it on the end. Okay, minus 46.710 K. Okay, and this is newtons. Now, what a lot of you did here, then at this point you went and you calculated the magnitude of A. If you calculate the magnitude here, if you square 32.697 and you add that to the square of 18, so if you square this and you add it to the square of this and you add it to the square of that and you take the square root, you're going to get the 100. Okay, and if you didn't, then you've made an error somewhere. Okay, so that's A. Let's go get B. Okay, let's see, B. All right, B. Woohoo! All right, now B is one of those ones that, to me, sorry, I'm dog sitting, little dogs. One of the things we need to do is the first thing we need to do is we need to get this thing down into the XY plane. Okay, so the angle that we're going to use for that is that 20. And we're going to note that we're using the sine of that 20 to get, the sine of the 20 will get this side, which is the same as this side right here, because it's the opposite, right? So this bottom is going to be B sine 20 degrees. Okay, this vertical side right here. Let's see. Here's the vertical side right here. It's hard to see. It's the same as this side right here. Okay, that's going to be B times the cosine of 20 because it is, adjacent to that 20 degrees. Okay? So this right here, that is parallel to the z-axis, so that's B in the z. Okay, this one right here, that's just in the xy plane, so I'm going to call that bxy. Okay, which means that once I have that thing, whatever it is, here I'll work in red now, I want to get the x and the y sides. So the x and the y sides look like this. So that's by, and here is bx. Okay, with the hypotenuse being b sine 20 and b being 80 newtons. Okay, so what we're going to do for x is, okay, so this is the cosine of that 50, right? And by is the sine of that 50, okay? Whether or not they're adjacent or the opposite, right? So bx in this case, I'm going to erase that, okay, because it's in the wrong place. Bx then is its hypotenuse, b sine 20, okay? But we only want the portion of it in the x direction, so we're going to multiply that by the cosine of 50 degrees. Okay, so this is the hypotenuse, and this is, dealing with the fact that we are the adjacent. Okay, so we're going to do a similar thing in the y direction. I'm going to say, okay, by equals the hypotenuse, b sine 30, b sine 20, sorry, times now we're the opposite, so it's going to be the sine of 50. Sine of 50. Okay, so that's kind of a lot of stuff. Okay, a lot of, you know, a lot of what have you. But basically what I'm looking for here is I'm looking for BZ, BX, and BY. Okay, so I can go down here and I can say, okay, well, B, how did I do it over here? Okay, I'm going to kind of line it up like I did over there. B equals, and let's see, in the x direction, sorry, we need this. So I'm going to do the sine of 20, the cosine of 50 in the I direction. Okay, noticing these all have a B in front of them. So I'm just going to kind of pull that out, okay? Plus, let's see, in the y direction, we've got sine and sine. Sine of 20, sine of 50 degrees in the j. And then we've got this vertical, which is the cosine of 20, plus the cosine of 20 degrees in the k. And then I'm going to leave b out front, you know, this b, which I'm just kind of pulling out of all of them. Okay, and that b is 80 newtons, so I'm going to put in 80 newtons out here. Okay. So what that yields, and I think just because I know I'm going to do a math problem with this, I'm going to put it over here. But if you multiply all of that out, you'll get B equals 17.588 in the I, plus 20.960 in the J, plus 75.175 in the K, okay? And again, I'm going to put the newtons out front, okay? So that's if we multiply these two and then multiply that by 80 and put it right here, okay, et cetera, et cetera. Okay? Now, I guess C is going to end up right here, but we'll go ahead and look at our diagram for C. We're also going to erase this because we're not working with that right now and it's in the way. Okay, so what's nice about working with the directional cosines, as they're called, is that basically we end up with the exact same triangle in all three directions. It's very hard to draw for something that's larger than 90 degrees. But what I'm going to do here is I'm going to draw for, that's kind of, let's move our screen a little bit. I'm going to draw the triangle here, if I can. And what we're talking about here is we're basically going to do a projection of that 100 newtons in each of the directions, right? So we're basically saying like, okay, cool. So here we go. This is, you know, so here's our triangle, okay? And this is a right angle, although it doesn't look like a right angle. It is a right angle, okay? And this C right here, this is the hypotenuse of the right angle of the triangle. And this right here, which is C sub Z, is the adjacent because it is adjacent to this side. So C sub Z, for example, in this case, is just 100 newtons, or C, times the cosine of that angle, which in this case is 73.677 degrees. Okay, and similarly, a similar line could be drawn for each of these. Not saying that these are easy to draw necessarily, but I could do it in the x direction just by drawing a line basically, well, not basically, exactly straight down. Okay, and again, this would be my right triangle right here, or my right angle would be right there. Okay, and I'd be looking for, this would be CX right here, CX, okay? And note that again, C is the hypotenuse, and this is the adjacent to that 35-degree angle. So CX equals 100 newtons times the cosine of 35 degrees. Okay, and that's just trig. Okay, in the y direction, because it's negative, that axis, it's much harder to draw. So we're not gonna play with that. Okay, and obviously even these drawings are a little wonky. I need to think about how to do them better in the future. But the nice thing is here, we're just going to basically, they're directional cosines. The reason they call them directional cosines, really it's directional angles, but we always solve them with cosines. So what we're going to do here is we're just going to, you know, pull out our three angles, and we're going to say, okay, well, C equals, well, the cosine of theta x, which is 35 degrees. That's in the I, plus in the J, cosine of 120 degrees. In the J. Notice, you know, there's a temptation to want to deal with the negative sign right now, But if I use 120 degrees, when I put in a cosine, it's going to give me a negative sign. So I either need to use 60 degrees and put a negative sign right here, or let's just use 120 right here. Okay, and I just recommend just, let the math take care of it for you. And then we'll do plus the cosine of 73.677 degrees. Okay, and all of that is going to be multiplied by, this 100 newtons. Okay. Oh, there's a K in there, isn't there? I always forget the K's. I'm racist against K's, or maybe racist is the wrong word. I'm a letterist. I'm letterist against K's. All right. So anyway, so we're going to put that over here. We're going to bring it over, and so we get C equals. Let's see. So if we plug all that into the calculator, because nobody's doing that by hand, or at least if they are A, very smart, or B, have a lot of time on their hands. Okay, minus 50 in the J, plus 28.105 in the K. Okay, that's newtons. All right, so to get the resultant, we're just going to add all three of these. So I'll draw a line underneath it, and we just add them up, right? So the resultant equals 132.20 in the I, minus 47.724 in the J, plus 56.570 in the K. Okay, and we'll give that units of newtons. Okay, now, unfortunately, it didn't ask for that. That wasn't what the third part of this problem was asking, right? It said add them up, so I guess it was asking for that in some levels. But the most important thing was, what's the resultant? Okay, what's the magnitude of the resultant? So if we add all these up, we'll say, okay, well, that means that R equals the square root of 132.20 newtons squared plus 47.724 newtons plus 56.570 newtons, all those squared. And we'll get that the resultant is, I get 151.51 newtons. And if you round to 3 sig figs, which is the way I like it, you get 152 newtons. Okay? And so that's how you solve this. Okay? So that's the whole thing. It has kind of a coolness to it, doesn't it? So anyway, so if I were grading this, here's how I would grade it. Well, I did grade this, right? So I guess this should have been multi-pages, but let's imagine all of this fit onto one page. But when I graded it, I said, okay, if you got the givens, you did 1. If you got the required, you got 1. If you made a reasonable attempt at these drawings, I gave you 1 for each. I might have taken off a point. There were a few things, like if you didn't use a right-handed coordinate system, or there are a few things. But because you're very rarely, if not never, going to be asked to draw these, I just wanted you to think about it. So I didn't really want to, that wasn't really the point of this question. So then we go, so that's 5 of the 10 points, of the 9 points, excuse me. And then down here, A was worth 1, B was worth 1, C was worth 1, and then the resultant was worth 1. Okay, now obviously, if you make a mistake on C, then you're going to get the wrong answer for R, but obviously I don't double count. So if your mistake on C led to a mistake on your overall R, that's fine. So I would have written DDC, so don't double count. Okay, so that's those are 9 points out of 9. So that's all I got. This is almost 35 minutes, so that's kind of long. But again, hopefully this makes sense. Hopefully this was helpful. Take care of yourselves. Remember, you are more than an academic person. Okay, we value you more than any of this stuff. So take care of yourself first, and then study hard. And let me know if I can help you. Okay, bye.